right triangle trigonometry, which hopefully will feel like a review based on stuff that you did in geometry in your freshman or sophomore year. And I'm going to start out by just showing you that this comes down to the unit circle that you guys would have looked at in a previous couple of videos. We've been working with that quite a bit. So just a couple of things. This symbol here is our theta, or our angle. All right, we've talked about this x and this y representing x representing the cosine of theta, y representing the sine of theta, and it also gives you these ordered pairs for your quadrantal angles, okay? So this whole kind of process is known as the unit circle. And what we're going to use today is taking apart kind of this, I think it's purple or blue in my drawing, just kind of pulling that out of the unit circle, that triangle, and thinking about it in terms of your days in geometry. So you'll notice we have this angle t, or you can say angle theta, it doesn't matter. And we have sides that are opposite, right? So that's opposite side. This is the adjacent side or next to, and then the side that is across from the right angle is the hypotenuse. So you would have remembered hopefully all of this from your days in geometry. And so what we want to think of is that sine, if I label this as the opposite side is y, the adjacent side is x, and you can use h for hypotenuse or you can use r, your choice. The sine of angle t is going to be y over that h, so the opposite side over the hypotenuse. The cosine of angle t is the adjacent side, or x over h, all right? And then the tangent side is opposite over adjacent, or y over x. Now, one thing I wanted to just kind of briefly show you is if you look at this kind of drawing here, this kind of gives you a good illustration of what the sine is, what the cosine is, based on these relationships with this right triangle. And then I like this one because it actually shows you what the tangent is. All right, that length, all right, from this point for cosine theta, sine theta, that xy, down to back to the x-axis, that length is the tangent of your angle. And the reason I bring it up is because some of you will go on to take calculus, where you're going to spend a good portion of calculus trying to find the equation for lines that are tangent to curves. So this kind of gives you an idea of why we call it tangent, because if you notice, this length is tangent to this unit circle and it intersects at that point. All right. So again, not really a big deal for our class, but if some of you go on to take calculus, you'll think, oh, okay, I see why it's called the tangent. All right, let's get to hopefully a review. SOHCAHTOA. So this is a good acronym to know to help you memorize the different trig functions. So for sine, it's the opposite over the hypotenuse. That's the SO part. Ka in SOHCAHTOA is cosine of your angle theta is equal to the adjacent side over the hypotenuse. And then TOA, the last three letters, is the tangent of your angle theta is equal to the opposite side over the adjacent side. So remembering this is going to help you be successful with some of these questions. So let's go ahead and do that. Use that to find sine, cosine, and tangent of this angle t. So I'll write down sine of angle t, cosine, and tangent of angle t. So sine in SOHCAHTOA is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. All right, so let's see. If we're thinking about the sine, all right, from this angle t, right, opposite side is over here. This is our adjacent side to our angle theta. Remember, it does depend on which angle. If we changed the angle, it would change what is our opposite and what's our adjacent. But what does not change is the hypotenuse. The hypotenuse is always across from the right angle. So the sine of angle t is going to be 7 over 25. The cosine of angle t is 24 over 25, so that ratio. And the tangent is going to be opposite, so 7 over adjacent, which is 24. So that's kind of the way I want you to organize this when you're working with these trig functions. Now, we've talked about reciprocal functions in the last lesson. All right, so remember to think of like SC, CS, so sine and cosecant, cosine and secant, and then tangent and cotangent. So in this case, we're talking about that same triangle from before, right? If you have, this is other reciprocals, cosine, sine, and tangent, right? And so if I flip them, I'm going to get these reciprocal ones. So cosine was the adjacent side over the hypotenuse, or x over h. So when you flip it, you get h over x. Cosecant is the reciprocal of sine, and sine was y over h. So this is going to be h over y. And then if I flip tangent to get cotangent, that's flipping y over x, which becomes x over y. Right, and hopefully that's not too bad because we have worked with reciprocals already in this unit. Okay, so let's use all that to find 6 of them, not just 3, but let's find 6 of them. Like before, I'm going to write down sine, and then the reciprocal of that is cosecant. Cosine of angle t and its reciprocal secant. Tangent of angle t and its reciprocal cotangent. It's not like imperative that you do that. I just think it helps your brain understand that, you know, the ones that are across from each other are reciprocals. All right, so if angle t, or my angle theta, is here, the opposite side is going to be 33, the adjacent side is going to be 56, and the hypotenuse, which is across from the right angle, is 65. The sine of angle t is going to be opposite, so 33 over the hypotenuse, 65. And I think it's the logical next step is actually to find the reciprocal. So cosecant of angle t is just flipping that fraction, 65 over 33. The cosine of angle t is adjacent over hypotenuse, so 56 over 65. And let's find the secant, which is that reciprocal, 65 over 56. And finally, tangent is opposite over adjacent, so 33 over 56. And the cotangent would be to flip that fraction. And that's all 6. All right, we only have one more to do. This is a pretty quick lesson here. One more to do to use right triangles and that trigonometry that comes with it to find some applied math problems. So if you look at this kind of sketch here, we have the angle of elevation is that angle that is created from the ground. And I always think of like a person looking up at the top of this object, I don't know, cell tower, radio tower, oil rig, whatever you want to call this here, right? Looking at the top, that creates that angle of elevation. And then the angle of depression, which is probably the more confusing of the two, is that angle that's created from the top of your object looking down to the ground. But a lot of students think it's going to be this angle, and that's not it. It's created with the horizontal, right? So think about horizon. It's created with the horizontal, or an imaginary horizontal line up there, just like this one is created with this horizontal line from the ground. So always think it's got to be touching. The angle has to be touching some type of horizontal line. If it's not, then it can't be an angle of elevation or depression. All right, so let's use all that to figure out how to answer this. So we have a ladder. I'll just draw a ladder. Sure, this would be terrible. So there's my ladder. All right, and it's reaching up to a windowsill. All right, so some type of windowsill. All right, I'll just say here's my window. Okay, and it says the windowsill is 50 feet, so 50 feet above the ground. All right, the ladder is resting against the building, making an angle. So I'll make my right triangle here, right, just a sketch. All right, and it creates an angle with the ground. So this angle theta, which is going to be 5 pi over 12. So I'm trying to figure out the length of this ladder. So I'm trying to figure out this side. How long does the ladder need to be for it to actually reach this windowsill? Okay, so what I notice, and I know maybe I'll write it here so it's a little bit easier to see with this triangle. So if this is 50 feet, all right, and I know this angle theta, looks like I'm trying to find this length that is, let me use a different color, trying to find this length, which is across from the right angle. So I'm trying to find the hypotenuse. All right, so I know that when I think about SOHCAHTOA, I'll write down all of that. All right, immediately I'm not going to use TOA or tangent because tangent doesn't have hypotenuse in its three-letter acronym, right? So I need to use either sine or cosine depending upon which other side I have. And if you notice, this side length of 50 feet is opposite that angle theta. So this is the opposite side. So that means I'm going to be using sine because I have the opposite side and I'm trying to find the hypotenuse. So I'm going to write down the sine of 5 pi over 12 is equal to the opposite side, which is 50 feet, over the length of my ladder. All right. Now, I need to solve for that ladder. So I am going to move the ladder to the other side so that it's out of the denominator. But you'll notice I need to take this sine of 5 pi over 12, and I need to move that to be on the other side of the equation. So when I move that over, it moves to the denominator. So you have 50 over sine of 5 pi over 12. So when I type this into my calculator, it will give me my length of ladder that I need. All right, it says around to the nearest foot, so I put approximately. So let's go to Desmos. And one thing you should notice is this angle of 5 pi over 12. You'll notice that it doesn't have a degree symbol, so that means our angle is actually in radians. So just be sure that whatever calculator you're using, whether it's Desmos or something else, that you are actually in radians. So hit this little wrench up here on the right-hand side and make sure you're in radians. We are, right? There's degrees, there's radians. So we are in radians. So let's do 50 over the sine of 5 pi over 12. All right, which is going to give us, rounded to the nearest foot, approximately 52 feet for the length of our ladder. So 52 feet. All right, so that's it for this lesson. Make sure to try the practice problems and come see me if you have any questions. Good luck.